Over the last couple of years, I've actually built 4 similar but different amplifiers using this case. The reason I've largely used this case is because it's one of the most cost-effective ones that you can buy from AliExpress and such places. I guess it's probably made out of surplus components because every one I've purchased so far has been different in some way or another, ranging from the heat sinks, which have been slightly different, certainly the front panel, and a couple of other bits and pieces. But saying that, for the money that it costs, you get the heat sinks with it, which is obviously a major purchase on any powerful amplifier. Now, you may notice there's a few things not quite right with this amplifier. The first one is there's no knob on the on-off switch. The switch is in there and in actual fact it doesn't work at the moment because it's not wired. Didn't see much point as you've got to jam your finger in there to switch it on. Believe it or not, I've actually lost the knob that goes on there to switch the thing on. I had it when the amplifier parts first arrived, but where it's gone now, I just don't know. It's gone to a better place, I'm sure. This is not generally the way I finish an amplifier off, but I've had another senior moment, and the type of 4mm sockets that I put on here, I've ordered the wrong ones. This is the combination of things that I've ended up with. I've looked at all the amplifiers and tested the ones that I've built before, and this combination is the one that I will rate the best in terms of virtually everything, predominantly because it uses these L12 Mark II power boards. These are just excellent. I can't fault these in any way whatsoever. They seem virtually indestructible. They will actually deliver in excess of 100 watts. With this transformer, both channels driven into 8 ohms. In fact, one channel driven, they will deliver 120 watts into 8 ohms just prior to clipping. I'm going to show you separately in a minute where all these components come from, but this toroid is a 36036. It's rated at 300 watts. Now I know they could be Chinese watts, so we never know. But the main thing about this transformer is it has 2 separate low voltage windings of, I think from memory, 6 volts and 12/012, which is very useful for running the modules and even a preamp if you needed to. Now, this is looking at the power amplifier board, and you'll see here, if I get my finger out of the way, a little preset potentiometer, and it's a multi-turn. Now, I'm going to show you what to do on this, because as the amplifier comes, the quiescent current tends to be slightly on the low side. And also, because I've now had probably 8 of these modules, the quiescent current does vary from one to another, because obviously it's relying on the tolerance of the resistors and mostly transistors. Now, it's a very simple modification to do, but I have to confess at this stage that I've already filmed this video once when the amplifier was all in pieces, showing you precisely how to do this. But due to a senior moment, or it could be Windows 10, I'm not quite sure which, I have a fairly good suspicion it could be either, I've lost all my footage. So this is by way of a sort of excuse of a reshoot, but I'm still going to show you the main things. So let's have a look at this. Right, now I have to say that none of these modifications is directly my doing. This is just information collected from the internet and these details are, I wouldn't say widely available, but if you look hard enough you'll find them. So this is the circuit diagram of the L12 Mark II, and this is where we're going to change something. So let's have a look at that. Now, in the original circuitry, this pot doesn't exist, and this resistor is in fact a 1K. And you will find, if you buy the kit or you buy it ready-made, that will be a 1K resistor. Now this is a drawing of the PCB. So we're looking at the 1K resistor 19, which are coloured in yellow, and is very easy to find on the board. But this is what you need to do. That resistor needs to be removed and replaced by a 1.5K. And you also need to purchase a multi-turn 5K linear potentiometer. Now, you could get away with a single turn pot, but they are so critical, you've only got to just tap the pot and the quiescent current will change. So go and get a multi-turn. You can usually recognize the ones I'm talking about because they tend to be blue. This is the 1K resistor, now replaced with the 1.5K resistor 19. And here's the 5K pot, wired literally as you can see there. One end of the pot goes to, doesn't matter which way round, and the other end goes to there. And the wiper goes to one end. It doesn't really matter which way round you put it, because all you're doing is shorting that resistor out across there. It just means you'll turn it in a different way. Now, what I would suggest you do, test the amplifier before you do these modifications, and bearing in mind the original resistor was 1K. Once you've put this together, put your meter across there and adjust the pot so that the total resistance is still 1K. So when you put this into circuit, you won't have any nasty surprises of 6 amps quiescent current or something like that. So very simple, test meter here, test meter there, and you should get 1K, and adjust the pot here until you get 1K. So when you put that into circuit, it will be as if you haven't done anything. Now, when you come to mount these pots, you do need to mount it at an angle. Imagine this is the PCB with the components on here. Make it so the pot is at an angle like this, because obviously you need to be able to get your screwdriver in here, or preferably your proper tool for adjusting it. If you put it like this, you won't be able to adjust it. Now, once it's all assembled, this is where you need to measure the quiescent current from here to here. Now, forgive me for those of you that find this a bit long-winded, but I'm trying to explain this so that people with, I won't say no knowledge, but little knowledge will be able to do this and get results. Now, the test points, this is the left-hand side of the board, and the reference is these 3 transistors are at the top. Again, it's easier to show you on a drawing than it is the real thing. This is the pair of output transistors and a similar pair on the opposite side of the board. These are in parallel, and the collectors are the center pin on obviously both transistors. So you can put one lead on your test meter onto the collector of that. It's easier to use that transistor because it's near the top. Depending on how you've mounted it, you can pick it up there. And the other side is absolutely identical. You just go to the collector on that side and that side. Now, a good bias is actually between 35 and 40 milliamps. Now, the only way you could really measure that would be to remove the resistor, and you don't want to do this. This is completely non-intrusive. You need to adjust it, not for milliamps. This is a misprint. It should be millivolts, which corresponds to this current here. So you put your meter on there, and when you first turn the amplifier on for millivolts, and that will creep up very quickly to around about 7 millivolts, which is what most of these amplifiers tend to come out at. But you actually wanted a bit more than that. I've set mine to 8 millivolts, which is a good compromise between the 7.7 and 8.8 millivolts, not amps. And you'll find that once you've set that, leave it to cook for 15 minutes or so, but the quiescent current is very, very stable. It's among the most stable I've found in any amplifier. Then give it some welly, give it some stick, make it hot, and then measure it again, and you'll find once you remove the signal and the load, it will very, very quickly drop down to the nominal 8 millivolts. Saying that, even with the lowest setting, you cannot see any crossover artifacts. I've looked at it on 20 kilohertz, because if you're going to see crossover distortion, the higher the frequency, the more likely you are to see it. And even with the bias low, or relatively low, there's just no crossover artifacts on the distortion residual at all. So that's why I think the designer has given you 7.7 to 8.8 millivolts. So setting it to 8 would seem to be a nice figure. Now, I have said the amplifier is actually finished, apart from the on-off switch and the speaker terminals, but you'll find that there's some wires much longer than they should be, and it's a little bit untidy, simply because I haven't done the final shortening of cables, because originally I had the heat sinks off and so like an exploded view, so I could work on them. And obviously if you have the lead short, you can't get inside very easily, so don't judge my neatness, because it will get better. Now, I don't really want to go into great detail, because all of the products, all the ingredients in here, I've been into fairly good detail on previous videos. This video is really just to say, if you're thinking of building one, of all the designs that I've proposed and all the various ingredients, this is the one I would go for. Don't use a switch mode power supply. It seems like a cheap way out, but unless I've been very unlucky, and some of my viewers also, they're not reliable. Whereas a transformer, theoretically, will last forever. And although this is a 300 watt transformer, it doesn't even get warm. It really doesn't. I'll send you some links to these so you can get them if you want. Now, the only thing I would say about the amplifier modules is this. Now, this is looking down at the 3 transistors that are bolted to the PCB, and they share a common heating bond, if you like. Be very careful when you get these, because the very latest version of these, the screws that are supplied, are way too long, and they will actually touch the heatsink. So you either need to replace the screws or saw them off. As stands, this amplifier with the ingredients I'm showing you here will produce 120 watts into 8 ohms both channels driven just prior to clipping. The other thing I would suggest you do is to fuse. I use these inline fuses simply because there's not really anywhere else to put fuses, because you need 4 altogether, one for the positive supply and one for the, helps if I'm pointing in the right place, doesn't it, and one for the negative supply, and you need that for both channels. Now I fuse these at 2 amps. If you're going to run it hard into 4 ohms, you may need to increase those to maybe 3 amps, and I always use quick blow, because if something goes wrong you want it to fuse quickly. It does have speaker protection from this board, and the reason I use this particular board is, unlike most of them, it separates the negative speaker return, whereas most of them don't. They just join them together, and you only really want these earthed at one place, and that's here on the power supply. Excuse that lead, this is one of the ones that needs to be shortened, but here you have, let me find something to poke this in. I'll use a pencil. It is disconnected, so quite safe. This is the negative. There's 2 negative supplies, which is exactly what you want. That 1, 2, 3, 4, 5 are all grounds, and that forms star earthing, so everything that's grounded goes back to there, and the last 2 terminals here are your positive, and you will get about 50 to 52 volts plus and minus on there, which is exactly what you need for these modules. This is the rectifier board, and it's available in kit form or finished board form. In all honesty, you might as well, whatever your skills, use the do-it-yourself kit, because you'd have to have minus knowledge not to be able to work this. Very easy, reliable, and a great board. Again, a great little board, a fairly good quality pot. You can get slightly better, but for the price, excellent. This is the cabinet. There are a number of different people that supply this. Some charge a higher price and it's postage included, but it's often cheaper to buy it at the lower price and pay the carriage. Not cheap, but it is very heavy, and that's the complete thing. This is a transformer, and as you can see from the details, it's 36-036, which is the high power winding, and it has 2 low power windings of 12-0-12 and a 6-volt supply. This is a 300-watt transformer. Again, recommended. Again, these are available in kit form and finished form. The difference in price is very small, and considering the amount of transistors on there, any of which could be out of spec, faulty, unless you have a good knowledge, I wouldn't economize. I would just buy the kits completely assembled, as in the photograph. I should perhaps mention that all these items have come from AliExpress, and there are multiple dealers that sell these things, and it's just a case of checking through quite a few of them, because some would have a sale one week, some will have another sale another week, so you could save yourself a bit of money. Now this, to my knowledge, is not available in kit form, but saying that, again, it's silly cheap and is the one I'd recommend. The grounds are separate on both channels. Very important. You can get cheaper ones for half that price, but they do compromise, and you don't want earth loops. Now, you may think this is an odd thing to recommend because it's pennies, but these are really good quality and not a lot of money, but the main thing is they fit the little board, and the mounting holes on the metalwork of the chassis. I'm sure there are many that would also do that, but they do have to be able to fit the little board with the relay on. So this is where I purchased them from, and you've got to pay a whole 7 cents postage on these, so you better start saving your money. Now, if you do need a bit more gain for whatever input you're going to use, you can use one of these little preamps. I've described these previously on my channel, and although they are simplicity itself, they are very good after you modify them. Again, I've been into this on the review of the basic units. This one has the advantage stroke disadvantage that it runs from a single supply, hence all these capacitors. This one runs on a plus and minus 15 volt supply, hence the lack of capacitors. So there is no capacitors in the signal path of this at all. These capacitors here are purely on the supply rail. So in real terms, this one is probably sonically the better, although I have to say I cannot hear any difference between the two. They cost pennies and they use a very good chip that's been around for many years and is low noise, wide bandwidth, and has a neutral sound. I mean, literally, people say, what do these things sound like? They don't have a sound. And if it does have a sound, there's something wrong with it. It shouldn't have a sound. All you want from a preamp, providing you don't want filters, bass and treble controls and other things which will severely colour the sound. I don't care what people say. If you tamper with the frequency response, and you'll get phase shift and other problems, as well as introducing a degree of distortion. If all you want is gain, that's all you need. And I know this sounds ridiculous when you see preamps on the market for thousands of pounds, or dollars even. It loosely comes under the heading of crap. A preamp is a device for giving you gain. The exception to that will be if you're running a magnetic cartridge. Now, neither of these are suitable for a magnetic cartridge. This is purely for a flat response from a telephone, or I might have to stop calling them telephones, smartphones, beg your pardon. That's all you need. And I'm embarrassed to say that. I mean, I'd like to show you something that costs thousands, but the minimal amount of components, but saying that, this has dozens of transistors inside it to get the operating conditions, and so don't just think, oh, that's just one little chip, that's not going to do much. But if you were to make that in discrete components, it will be on a board about 6 inches square. So, take my word for it. Well, you don't even have to do that. These cost pennies. Just get one and try it for yourself. And if you don't think I'm right, then tell me about it. Say what you think I'm saying is wrong. But as it stands, the amplifier, if you're running it from a PC or a laptop, you probably will not need a preamp. I've never used a preamp on any of the amplifiers that I've demonstrated on here before, including the valve one. So there we have it. 100% recommended, and for what it costs, it would be equivalent to something costing treble if you were to buy it as a ready-made unit from a shop. Nice big heat sinks that even when you're caning it, only get warm. They never get hot. They might get a bit toasty into 4 ohms at high power, but you'll be lucky on a commercial amplifier to get a heatsink half this size, and both channels will be on it. So let me know what you think if you've decided to build this combination, and why not make a video of it? thanks for watching this series, and this really, I promise you, is the end to this series. I don't know what I'm going to do next, but you can be sure it will be audio related in some way.